My name is Tony Holtz-Brown. I work at Ingest, one of the founders, and I'm here to talk about stateful Next.js serverless functions. Um, and that kind of seems like an oxymoron. Stateful serverless functions isn't necessarily a thing. You might question, why does it even matter? That's a really, really good question. I think one of the interesting things is that the bar for product has gotten really high. As I think was it pronounced foul? As you showed, you can build UIs really, really quickly. And Next.js has made it really, really easy to iterate alongside, the cell with serverless functions. You've got your branching previews, stuff like that. Um, it's really, really hard to build modern products. And it turns out that in backend, it just hasn't really kept up. It would be ideal if you could deploy something like Next.js with your entire serverless functions, your backend, end to end, not just your CRUD stuff, and have everything work with branch deploys, stuff like Neon tied in. And I'll quickly talk about some of the problems and some examples. Right now, it seems as though serverless functions might only be good for CRUD. Not in that feedback is bad, and posting to a database is bad, but if you want to build complex things like Mux's video pipelines, which you shouldn't do, you should just use Mux. You can't really do that in a serverless function. And if you wanted to rebuild all of your indexes from Strapi, say for example for RAG, or you wanted to do embeddings, that sort of stuff is really tough to do in a serverless function because you've got timeouts, it kind of errors, you might have memory issues. It's in general kind of hard. Or if you take something like Resend, which under the hood is like, okay, cool, you send emails, but you need to do a lot of complex stuff with timing. The main verification, it turns out, is a little bit of a challenge. You can't do that on a serverless function because DNS is slow. The user might not have updated their DNS settings when they begin clicking the button. It might not propagate it. So you need to do this sort of annoying reschedule flow. You need to add state to your serverless functions in order to make it work. And this is where the sort of Next.js split happens. When you deploy your functions to Next.js, you've got your server routes, you've got your use server, all the fancy stuff they came out with in Next 13, 14, 15, which is cool. But then you've got your backend somewhere else, which kind of sucks. And then what do? You pay extra money to try and sync up your branch deploys, or you try and figure out how to get branch previews working with your backend. And then you try and figure out how to make that work with queuing systems. Doesn't quite work. And the ideal state would be if we can just push all of this state to serverless functions, and you could make your serverless functions work end to end. So you could have one mono repo, build all of your code, ship, and then kind of call it a day. And the idea is, what could we do to make that happen? How is this possible? Some of the complex flows we talked about here, simple steps. You can walk through Resend's DNS propagation and flows as a series of 3 simple steps. And these steps can happen on serverless functions if you inject state, which we'll talk about in a second. Firstly, ping the DNS servers, respond, see if that works. If it didn't work, reschedule the serverless function to run at some other time. You could be smart about it and take the TTLs from the DNS server. Maybe they didn't update that yet, so there's no TTLs. So you do it in like 60 seconds or 2 minutes. It doesn't necessarily matter, but you just reschedule the function to happen. And then once you ping the DNS records, rerun it again, update your internal records. If that failed, which it wouldn't if you're using Neon because they're great, if that fails, great, reschedule the function, retry, and then finally send your notifications to the user to enable the account because, spam is a thing and you don't want that to happen before the DNS records are verified. Relatively simple flow, 3 steps, not hard to do. Each one of them can fail, as we've talked about. And you also have the same thing with another company who does, AI. In this case, they are taking content from Strapi, analyzing your entire website, figuring out what pages you have, what content they look at, figuring out the keywords that they target, and then writing content to talk about those keywords for SEO. And all of those are kind of crazy multi-step pipelines that happen in the background that would be really hard to do on serverless functions unless you had some sort of stateful orchestrator. And that makes everything particularly easy. It turns out that it totally is possible. It's not actually that hard to do. And the answer is workflows, which are essentially step functions. This is an example of said workflow. If you ignore some of the stuff over here with the setup, you can see that there's StepRun to get a page content. and then the step.index page to save to Pinecone or Neon, because PG Vector is great and you shouldn't use two databases. In this case, if the first step fails, we can reschedule the step function, run the step again, because you have state injected into the function. Once this finishes, we save that step run data in some function run state, rerun the function, and inject that data directly into the function on any platform, serverless, so Vercel, or it could be anywhere. And then we skip that step, run the next step. And this allows you to build really composable workflows. If you do step.sleep, for example, if you want to do the DNS propagation thing, you can say, hey, reschedule this function to run in a minute. And then you can start building your entire backend in a really simple, composable way without having to leave Next.js, without having to deploy separate services, which is kind of cool, because if you can do that, you get all of the benefits of Next.js and the environments that you get with the sort of modern toolkits like Vercel. And if you're building these really complex things that do a bunch of AI as steps, which a lot of people do, you can then start testing everything end to end with branch deploys and branch previews. And it's kind of super easy. Don't actually have to change anything. The definition of a workflow, pretty simple. You have function ID that's triggered by an event, and super simple to run. In general, kind of like memoization on steroids, really. I don't know if you looked into like memoization and caching, but realistically, cache a step.run, inject that state into the function, and you're kind of good to go. This is super easy. Step.run is a simple API that I think a lot of people will start using. We obviously offer it at Inngest, but I think a lot of people are going to start offering this API in the next couple of years, which is super interesting because hopefully this can become a standard such that it's really easy for you to build simple orchestration without having to worry about queuing systems ever in general. And if you can do that, then largely you've got the front end, which is super easy, the database, which is kind of handled for you. And then everything else that you typically do on the back end can be rolled up into one platform, which is makes development a lot easier. So gives you a bunch out the box, way better system to develop with than having this separate back end, and kind of cool. Yeah. Any questions? Super quick.
What signals are you seeing that you mentioned that this might turn into this kind of pattern? Just from your perspective, what signals are you seeing that make you say this kind of pattern might be adopted through almost like OpenAI's SDK, where it's a pattern everyone uses?
Yeah, totally. So we had the question is, why will this turn into a standard? And what patterns or signals are you seeing that will make this a standard? In order to answer the question, I'll talk just historically real quick, why we built it, how we designed it, and then what we've seen over the last just 2 years. Built it 2 years ago because it was totally necessary to make a bunch of healthcare flows work. Healthcare is crazy. Do not join a healthcare company. If you are in a healthcare company, full respect to you. Very good. We released 2 years ago, and since then, we've seen a bunch of people take step.run and actually run with it. We've seen a bunch of other people from YC take it and run with it, which is cool. We've also seen a bunch of other companies like Netlify try and introduce step.run, which they did at their conference last week. And it is literally our API, which is cool. Cloudflare have also signaled that they want to build the same thing. Obviously, it will be on Cloudflare's system, and it will be using the same API. And so in general, I think the API that we've built will end up becoming a standard that will be on many different clouds, which is super cool. And in general, that should mean, these sorts of systems are the way that we build. Yeah.
Don't forget to repeat the question.
Taking my job, man.
Would you like to compare this to a traditional message queuing system?
Yeah.
Queue or something familiar. I already love it, but just want to.
Yeah. Sure. Question is, would you compare this, or could you compare it to a traditional messaging system? And this is Next.js. I'll quickly talk about messaging systems overall for the front-end crowd in case people don't know. General event buses, decouples one service to another. messaging systems are cool, they're good, and they've existed for a bunch of time, but they're sort of commoditized. They're dumb pipes, as it were. If you can build functions that respond to events, number one, yeah, send your events over to Ingest or some other platform. Number two, yeah, you get fan out, so many serverless functions can run. But if you can build it in a smarter way, such that if we take a look at some of these things, the function knows the events and it knows the event name. We can take the types, the schemas, just like you get with Avro and whatnot, and build a schema library. You can also store these events, do flow control. So you can say, you got a high volume function, sales kind of expensive. Maybe you want to batch 1,000 events into one function call so that you lower your costs. That's super easy, and it's just a batching config in your function. So largely, same decoupling, better developer experience. You can test locally with one command, and it runs anywhere, which is one of the tough parts with serverless. Like, this is kind of why I feel like, I've loved serverless for some time, but it's been hard to develop end to end because it's, CRUD-like. You can't build these complex backends. And so similarities for sure. Very, very, very different use cases. And actually there's a lot layered on top, like batching, debouncing, throttling, concurrency to make it work.
So I assume you invoke these workflows through like a server action. And then is there a way to subscribe to kind of the updates of that function, and how do you manage that?
Yeah. So these are, you send an event over from any particular system. You can like allow or deny list IPs or event names for public keys if you want to send them from the front end, for example, page events. Or if you don't want to do that because security is a thing, server actions. Can you subscribe? Yeah, theoretically. We actually don't do real time right now because, well, largely we see a lot of people building really complex flows. The flows that I've described over here are all largely backend heavy. If you were going to build an API endpoint, you might want to subscribe to that, and that's actually something that we are building now. But right now, it's largely focused on your backend orchestration. But yeah, it's totally easy and possible to build. You just want to make sure that like things are low latency, things are fast, and security is a thing. Like if you're doing backend orchestration, typically kind of keys to the kingdom. We've got people that do insurance for healthcare, and they run a bunch of insurance flows, and you would not want people to be able to get the output of those results. And so, just making sure that everything is end to end done really nicely is important before rolling it out.
Build this up.
So maybe you don't mind going back to the snippet. I'm curious how close this is to Uber Cadence or other workflow orchestrations. And like, for example, this page URL, are you doing things based on like where you serialize the closure, and so you're having to have this file be specially kind of like imported by ingest, or are you doing checkpointing at each step?
Yeah, it's a good question, right? So many considerations here. And I'll talk about some of the considerations, and I'll talk about Uber Cadence and how that stuff works. Your considerations of serverless functions are obviously time limits, memory, shutdown, random failures. Your considerations with function state are checkpointing and how to make it as close to exactly once as possible. For people that don't know, Uber Cadence is a system that came out something similar like this, like 2015, 2017. APIs are, you can look at them and see for yourself, but they built a lot of similar things and principles, and respect for them for that. Somewhat similar, event-driven, which is a big difference. One event can trigger one or more functions instead of the RPC start. Because it's event-driven, you can do interesting things like step.wait for event with an expression. And then you can pause your function, whether it's on serverless or Kubernetes or whatever, wait for something specific to happen with a timeout, and then resume the function automatically when that event is received. Or if it times out, the variable will be null, and you know that thing didn't happen. And because it's event-driven, you can do things like look back. So if you've got click cancel, that sort of stuff, no race conditions, basically. Very similar. Yeah, we do checkpointing after each particular step because serverless functions and timeouts are a thing. And the way to sort of manage that is checkpoint after each particular step, rerun the function, and make sure that it starts anew. Although there's different modes of running, such that, you can just automatically run down, which reduces latency, but obviously in serverless functions may not be what you want.
So you memorize the steps and don't rely on like serializing the closure.
No, we memorize the steps. And this is something interesting as well. Like, if you're going to build these workflows, which I think over the next 5 years will become super common. You're going to end up changing them over time. And I don't know how many people here have worked with queuing systems or built some complex stuff in the back end. And they realize that, fuck, we need to change this code, and this code has already been enqueued like 1,000,000 times. And like, how are we actually going to make this work? That is no fun. Versioning and this sort of thing is kind of weird. You can see that we add step.run and there's an ID, which is get page content. Each particular ID is hashed with an index, which is the number of times you've seen that ID. And that becomes the hash key for the function state. So if you want to change things, it's super easy to change the ID, and it will rerun, and it will rerun that step. It also means you can do steps in a loop without doing your own identifiers or counts, because, we store the counts for you. And then it means if you reorder things, technically you can do one of two things. You can store the entire stack, which is the order in which you saw every hash. Or you can just do a straight lookup and say, you know what, you reordered it. You're in like lax mode. I don't know if people remember use strict back in the day with JavaScript. Like, why don't we just throw that in here and then you get your own sort of stuff, This format and this API is, I guess, like one of the principles that you learn in engineering is like explicit versus implicit. This is extremely explicit to the point where I think that's why people are taking this and running with it overall. And it's much simpler to reason about.
So like, maybe I missed something, but why doesn't this time out? Are you rerunning this?
Yeah. The question is, why wouldn't this time out? And are you rerunning this? So yeah, in between each step.run, function state is memoized, cached, re-injected into the function, and reran. And that means that each particular step gets its own timeouts by default. And that is easy. Obviously, if you've got the 900-second timeout on the cell, you still have to abide by those laws. The same with like Lambda, you got your 15-minute stuff. That is sort of a defining feature of serverless functions overall. Google Cloud Run, I think, is 1 or 2 hours, which is kind of crazy. They're actually pretty cool. If you want to do serverless functions, that is kind of, this runs on your platform. So you get your own platform restrictions. We just rerun the function on every step.
Okay, so you just, like, I don't quite understand exactly how that works, but I
Yeah. Orchestration, we call your function when it needs to be called. And after a step.run runs, it sends us back the data. Function terminates due to magic that we've got in our SDK. And then it schedules another function call with the updated state to hit that function. It sees the updated state, skips the previous steps, and then hops straight to where it needs to be.
get it.
Yeah.
Because it's memoized.
Yeah.
So, is just serverless functions timing out just like a fact of life? I mean, is it?
Yeah, I mean,
have that be a thing?
it would. It would. Yeah, I mean, like it would be to a degree nice if you did that. But then I guess your questions are like, ECS is a thing. It's probably more cost effective to pay for ECS than it is to pay for a bunch of functions running. Functions do time out, platform specifics. We take the stance of we don't ever want to run your code because security is a thing. Come from a healthcare background. I don't want you to poke holes in your VPC to give us database credentials or that sort of stuff. You figure out where you want it to run, whether it's like bare metal and whatnot, and it will run. Serverless function timeouts, though, yeah, I don't know why the cell has such a small timeout. That frustrates me.
Okay, thanks.
Mm-hmm.
Do you have the usual APIs like, if you want to do a Stripe trial, like wait 14 days and then like...
Yeah. Wait 14 days, wait for event. Wait for event is cool because then you don't need to use like any crazy signals. You don't need to record any state. You can do automatic cancellation by configuring cancel on with an event as well. So if you're building some sort of AI flow and the user hits cancel, send an event that says it was canceled. Your functions will automatically terminate. Yeah, similar APIs, just ergonomic because it should be easy for people to use in general.
Awesome.
Cool.
Thank you so much.